Alright, let's take a look at 2.6, and 2.6 is essentially just using a couple different theorems we learned involving complementary angles and supplementary angles. So our first question here gives us some information, although it's not asking us to prove anything. We're just trying to find the measure of all these numbered angles. So you can see angle 1, 2, 3, 4, 5, 6, 7, 8, and what you'll notice is they give you the measure of angle 4 to be 131. So as I've taught you throughout the year, let's write that in place of that angle so we know how many degrees that is. It gives us a better picture of what's going on here. Now you'll notice angle 3 and angle 4 form a linear pair here. So we know that they're supplementary, which means that their measures add up to 180. So if you want the measure of angle 3, all you have to do is take 180 and subtract out 131. So we get 49 degrees. Okay, so we have the measure of angle 3 now. And what you'll notice is also these lines are crossing here. And when we get lines that cross, we get vertical angles. So we know angle 4 and angle 6 are congruent. So if the measure of angle 4 is 131, the measure of angle 6 must be 131. Same thing with angle 3 and angle 5. Good. Now, what's going on with this bunch of angles at the moment has nothing to do with these angles over here. But it is given that angle 2 is complementary to angle 3. So what do we know about angle 2 and angle 3? You should know complementary means measures that add up to 90 degrees. So if you want the measure of angle 2, just take 90 degrees and subtract out the measure of angle 3, which is 49. So we get 41 degrees. Okay, now that we have the measure of angle 2, it should be easy to find the measure of angle 1, since these two angles form a linear pair. Getting 139. And once again, we have vertical angles, angle 1 and angle 7. And if we were to write these out beneath the problem here, we can write this like this. Measure of angle 8, for example, equals 41 degrees. Remember, that's how many degrees. That's why we use the little m there. That stands for measurement. So it'll give us an actual number. Measure of angle 6, 131 degrees. Question 2 here, we have a few givens and we need to prove that angle F is congruent to angle H. So let's start out how we always begin a proof, with our givens. Angle F is complementary to angle FGJ. So I'm going to highlight these here. These are complementary, which means they add up to 90. Then we also know that angle H is complementary to angle HGJ. So those are these angles here. This is just how I'm notating these so we can get an idea of what's going on here. And then lastly, we have this bit of information, GJ, ray GJ bisects angle FGH. So this angle here, angle FGH, is being bisected. So this whole angle here is being bisected by ray GJ. And if you use the definition of bisects, the definition of bisects tells us that if a ray, line, or segment bisects an angle, then it cuts that angle into two congruent angles. Therefore, we know all this that these two angles are congruent. This one and this one. So we will write in our next step, by definition of bisects, we know angle FGJ is congruent to angle HGJ. Now, before we finish this proof, because we're actually ready, all this information is primed. We know these are complementary, we know these are complementary, and then we know that those angles that they're complementary to are congruent. Let's look at the congruent complements theorem. If angles are complementary to an angle or congruent angles, then those angles are congruent. So we have this scenario going on. A is complementary to angle B, C is complementary to angle B, so we know that these are congruent. In the case of the proof that we're looking at here, we have that they're complementary to congruent angles. So imagine I had another angle, and I'll highlight this and copy it. Let's say this were angle J. If I knew that these angles B and J were congruent, and I knew that C and J were complementary, A and B were complementary, then we'd know that angle A and C have to be congruent. So we're going to use the congruent complements theorem to make our final statement. Which is that angle F is congruent to angle H. Just a three-step proof, nice and simple. So this is the picture we have here. These are congruent angles, angle F and angle H. And I'll give you some numbers so that you can sort of see what's going on here. If we're given that these two are complementary, and let's say angle F was 60 degrees. If these were complementary, it means they add up to 90. So this angle FGJ would have to be 30. Now, since GJ is bisecting this entire angle, we know that these are congruent. So this angle HGJ has to be 30. Now, also one of the givens is that these are complementary, these two angles. Therefore, angle H must be 60. So, at the end of the day, what do we know? Angle H is congruent to angle F. Cool. We got time to look at question 3 here. What we're given is that CD is, and do you remember this symbol? You need to remember what this symbol means. It's perpendicular. Perpendicular, what does perpendicular mean? Well, by definition of perpendicular, we know that when two lines or rays or segments are perpendicular, they form right angles. So, after writing down my givens, I can use the definition of perpendicular to say that angle, we should know it's angle CDE, that's a right angle. Cool. Now, my goal is to prove that angle CDF is complementary to angle FDE. And looking at the picture, it's quite clear, right? These two angles add up to make the entire angle CDE, and we know that angle CDE is a right angle. So we know they're complementary, but we need to make sure that we follow the logic of this proof, the sequence of reasons and statements. So I'm actually going to break down this information a bit more. I'm going to say by definition, can you guess, of right angles, I know that the measure of angle CDE equals 90 degrees. You'll see in a moment why I'm writing this statement. Now, my next statement I'm going to use the angle addition postulate to write the following equation. Measure of angle CDF plus the measure of angle FDE equals the measure of angle CDE. This is just the angle addition postulate. We've been doing this for a long time now, really since the first week of content, Unit 1. So we're just saying this angle plus this angle equals the whole angle, which we know is 90 degrees. Now I want you to guess what my next reason is for the statement I'm making here. I'll just copy this. Okay, what allows me to make this statement? Well, we know that all of this equals the measure of angle CDE, and we know that the measure of angle CDE equals this. So this is the transitive property. Technically, if you wrote substitution in this case, that does work because we're literally replacing the measure of angle CDE with what it's equal to, which is 90. Okay, now actually by definition of complementary, we can say that angle CDE is complementary to angle FDE. And we've finished our proof.